In this video, we're going to look at two types of symmetry that functions or relations can have, and that is referred to as even and odd. We're going to focus just on the functions. So the first type that we're going to look at is called an even function. So an even function is a reflection over the y-axis. To get a sense of that, this graph over here, this parabola, is an even function. I'm going to trace that parabola. And then we're going to take a look at what happens when we flip it. So choosing the parabola, we're going to flip that left and right. And then you can see that when I flip that, we get the same graph. So if you can fold along the y-axis and get the same graph, or if you think of it as the left and right sides of the y-axis are mirror images of each other, then that gives you an even function. Another way to look at it is algebraically. Algebraically, f of negative x equals f of x. So if we think about this point over here, let's say we're going to call this point, this is the point 2, 4. So if I know any point on the function 2, 4, so when x is 2, y is 4, so f of 2 gives me 4. So we would say f of 2 here, which equals 4. So if I do f of negative 2, so f of negative 2 is also going to give me 4. So this is the point negative 2, 4. So f of negative 2 equals 4. So this is simply saying that when we put in x or its opposite, we're going to get the same y value out. So this is the same y value for opposite x values. Another way to look at that is this is numerically. So if an even function contains some point a, b, so if we think of this as a, b, so if I have the point 2, 4, then I know automatically that if I change the sign of the x coordinate, I'm going to get the same y value. So if I have the point a, b, then I know that I'm going to have the point negative a and b. So we change the sign of the x coordinate only. So the other type of function that we have is called an odd function. This is rotationally symmetric about the origin. So again, I'm going to kind of try to trace this graph here. And in this particular graph, what happens is that if we turn this upside down, we get the same graph. So this is a rotation of 180 degrees. So essentially, look at the graph, completely turn it upside down, and you should get the same graph. If we think about this one algebraically, if I put f of negative x in, that should be the same as the opposite of f of x. So if we think of this point here, let's say this is the point, this looks like point 2, 1, 2, 3, 4. So over here, this is the point negative 2, negative 4. So when I put in the positive 2 and then the negative 2, we're getting opposite values for our y coordinates. So what this is telling me here is that I get opposite y values for opposite x values. And then also same thing that we talked about up here at the top. If I know a given point on an odd function, I can always find an additional point on an odd function. So when I'm looking at this one, here we have the point 2, 4. We changed the sign on the x coordinate, which also changes the sign on the y coordinate. So when any general point a, b is on an odd function, then I know negative a, negative b will also be on the odd function. So we're going to change the sign of both coordinates. So what we'd like to be able to do is to look at an equation or a graph and tell if it is even or odd. So we're going to look at a couple examples of each of those. So just looking at the graph, we're really just kind of asking ourselves, is this symmetric about the origin? Is this symmetric to the y-axis? Or are neither of those things happening? So not every graph will be even or odd. We'll always have the option of neither. So you can kind of trace that graph. Remember, if I trace this graph, in this specific case, if we rotate this one 180 degrees, we get the same graph. So this graph, we are going to say is an odd graph. So this is an odd function because it is rotationally symmetric about the origin 180 degrees. Over here, this graph, it's not symmetric to the y-axis. If it were symmetric to the y-axis, we would have to have another piece over here, but we do not. If I rotate this graph upside down, we're not going to get the same picture, so this graph is neither even nor odd. Continuing down, this graph here, again, if we were to rotate this upside down, that graph looks the same as what the original graph looked like. So I know that this graph is also going to be an odd graph or an odd function. And finally, this last one, if I were to fold along the y-axis, the left and right sides are mirror images of each other. So this is an even graph or an even function. So when you're looking at the graph, you're really just kind of looking for that some symmetry of rotationally symmetric about the origin or reflectionally symmetric about the y-axis. If we're working with some equations, what we can do is use the graphing calculator. So from an equation, what we want to do is just go ahead and graph that on our graphing calculator. So we're going to graph this first one here. So looking at the graph, at first inspection, it looks like it appears to be an even function. We could fold along that y-axis, and the left and right sides could be mirror images of each other. One thing you want to do is just double check them, and the way that you can do that is to remember the concept about putting in opposite values of x. So remember, for an even function, opposite values of x should give you the same y value. So I'm going to go second trace value here, and I'm going to pick an x value to put in. I'm just going to use 2. I can really use any value that's on my window there. So when I put in x equals 2, I get a y value of negative 1.1. So that means when I put in x value of negative 2, I should get exactly that same y value, and I'm not getting the exact same y value. So although initially that appears to be an even function, based on checking the two opposite values of x, I can see that it is not an even function. The 0.1 shift there gives it a little bit off from the y-axis being its line of symmetry. So this one is actually neither. Moving on to B here, I'm going to take a look at this graph. So this is a cubic graph, and again, this one appears from the graph to perhaps be an odd function. So again, I just want to double check because I have my calculator and I can do that. So we're going to do second trace value. We're going to put in some opposite x values. Again, any numbers that you want. Remember, with an odd function, you want to get opposite y values out. So here I'm just going to put in negative 1, and I get a y value of negative 7. So then when I put in positive 1, I should get positive 7, and I do. So based on checking those values, I can say that this appears to be an odd function. Okay, so for our last example here, we're going to take a look at this graph. And this graph appears to be an even function. It appears to be symmetric about the y-axis. So using our values to double check, we're going to put in some opposite y value or x values and check our y values. So I'm going to use negative 1, and I get a y value of 6.5, and then I'm going to put in positive 1, and again I get a y value of 6.5. If you want to check again, you can use some different values. So here I'm going to put in 3, and then I'm going to put in negative 3, and both of those times I'm getting y values of 2.5. So that confirms for me that when I put in opposite values of x, I'm getting equal y values. So equal y values means that this function is even.